So today we will continue our lesson in chapter 2. Hopefully we can cover significant portion of chapter 2 because of we have one day holiday, alright? So we'll speed up a little bit. Hopefully, if you have any problem, please ask straight away. Alright. Okay, insyaAllah. Bismillahirrahmanirrahim. Rabbi zidni ilma. Allahumma okay, Bismillah. Just to recall, we have covered how to deal with vector in 2D, and today we will continue with 3D. Right? And so one of the things that we have to know is how to present 3D vector in Cartesian vector form. Right? And then we can add the vectors, multiple vectors. Right? Okay. In real application, the application almost always 3D, right? Like this is 3D, right? It not never. Rarely we have application where it's in the same plane as we have covered in previous class, right? So why we cover the 2D is because that's the basic concept to make it easier to understand the more complicated thing, right? So that's why we need to know how to deal with 3D, right? This is another example. This is a 3D object, right? It have X, Y, Z component, right? So first thing that will be, because you already have touched on unit vector before, right? Okay, so this is just to refresh on that. Normally when we deal with vector, we have the right hand rule, but this one we'll save for the later chapter where we actually use the right hand rule. So unit vector, what is it? It is basically a vector. When we say unit vector, obviously it is a vector, meaning it's ijk, it has ijk component, but it is a vector with magnitude 1 that expresses the direction of a certain vector. For example, if we have let's say vector A, meaning if you have a vector where the magnitude of A, the vector will be expressed as such, right? And if you have a vector in the same line where the magnitude of 1, the vector will be UA. That is basically what it means, right? So why is it important and why we always use or why we always calculate for unit vector in statics or in mechanics? Because if you know a vector where the magnitude is 1 and where is if the magnitude is 2, you just multiply, and if your magnitude is 8, you just multiply by A times the unit vector, right? So it becomes a basic thing that we always calculate first, so that when we have any given magnitude later on, we just multiply to get the vector. So it makes life easy. So in that sense, so the characteristic is such, so magnitude is 1, and if you do square root of x, y, z component, you should get 1. It doesn't. It is dimensionless, because if you understand this one, if you rearrange, you get UA is A over A, right? So if A is meter, this is meter, the unit cancel. So if it's Newton and Newton, cancel also. So it is dimensionless, and it always points the same direction as A. So if you have B, UB, etc. Right? So that's how we express. So that's the concept of unit vector. Right? Any question on that? Is it clear? Okay. And considering that we have x, y, z axis, so if we have a vector in this direction with magnitude 1, the vector will be I. If we have 1 here, then the vector will be j, 1 here, the vector will be k. Right? So that's why when we have a vector in this direction with magnitude of 3, it becomes 3i because you multiply with it, right? That 3j, etc. We have already used this one without realizing normally, right? But this is the unit vector for x axis, y axis, and z axis. So sometimes if you know this vector lie on one specific axis, you actually do not need to actually calculate the unit vector. You know already it's I, for example, right? From understanding. So, alright, so that's about unit vector. Now, about 3D vector. So how to express? This is also something that I believe you have learned before. So if we consider a 3D space in the x, y, z axis. So if we have a vector like this, right? Let's say A. It means that if this is projected on this plane, it will be like this, and this is projected x and y. So it means that you'll have the x component and the y component, and you have the z component, right? And if you know all of these three components, you can express A as ax I plus ay j plus az k, right? So sometimes the task is to get what is ax, ay, and z, so that we can plug in to get the vector. Right? So this is one understanding in terms of that. Now, how does this relate to each of these? If we consider the triangle, right? If you consider in this case the light blue triangle, which is this one here, right? Where this is the right angle here. If you consider this triangle, it will look like this. If you look from the perpendicular to the plane of the triangle, right? And then this will be A. This will be a Z. This one is the same as a Z. Let's name this A prime. So this will be A prime, right? Which is this one, right? So the triangle. So how it relates is basically from Pythagoras A. Basically A squared equal to A prime squared plus AZ squared, right? Or A equal to square root of A prime squared plus AZ squared, right? And if you look at this triangle here, the grey triangle there, if you draw that, if you look from top, it will be something like this, where this is A x, A y, and A prime, right? So here you can say, is it? Yep. So A prime square will be equal to x square plus y square, right? And actually the whole thing of a prime square can be just plug in here, right? This is the same. If you plug in, you get a square equal to, you put this here, ax square plus ay square plus az square. So if you want to get a, it's simply square root of square plus y square plus az square. This is basically the how you derive this equation. You get a equal to ax square plus ay az square. So if you already know the vector where you have ax, ay, z, to get the magnitude, you can just square root of everything here. Right? So in terms of exam, you can just memorize and apply. It's good if you understand how it is derived, because the application can be more when you become an engineer, right? But for the purpose of static, if you just memorize this one, it's also okay in the sense of answering the problem. Right? So that's one of the things. Any questions so far? So that is what is expressed here basically, right? So you end up with a equal to square root of ax square plus ay square plus az square. Now, the angle can also be expressed in a different format or different way, because here it's basically it's projected angle, right? You also have a different format of presenting the angle, where, for example, if you have vector A and then you have angle here, which is alpha, beta, and gamma. You have learned this before, right? No. Have you heard? Have you? No. Oh, okay. This one? This one? Alright. So what is alpha, beta, and gamma? It's basically defined as the angle it makes with the positive x-axis, positive y-axis, and positive z-axis. Because x-axis is the positive here and the negative is on the other side. So even if the angle is slanting there, so it's still the angle to the positive side. So it can be more than 90 degrees. Right? So with this type of angle, it can be expressed as such. So we have cos alpha is basically ax over a, cos beta is ay over a, cos gamma is z over a. Meaning in a way, if you already have this one and this one, so for cos alpha is simply just this one over this one, right? X over a. Cos beta is simply this one over this one, something like that, right? Cos gamma, take this one over this one. So you can calculate the angle if you already know this one. Or in a different direction, if you know A and alpha, beta, and gamma, to express this one is simply just you multiply. So ax is just A cos. And if you're going to get this one, ax is just A cos alpha, ay is A cos beta, this one is A cos gamma from the equation, right? So as long as you know how to apply, then any given question you can use alpha, beta, and gamma. The equation you have seen before, right? In mathematics. Have you not? Cos square alpha plus cos square beta plus cos square gamma equal to 1. Because this one is from mathematics, so we expect you just already have memorized this one and can apply. This one will be necessary when, for example, the angle given is only 2. For example, it gives alpha and beta, it doesn't give gamma. So you should be able to calculate gamma from this equation. Right? And if you notice, all of this can be related back to unit vector. For example, unit vector, what is it? Unit vector is simply what? Basically, vector divide by the magnitude, right? So if you have this divide by this, for x component you have ax divided by a, which is this one, right? For the y component will be ay divided by a, which is this one. For z component is az divided by a, which is this one. So it's as it can be also expressed as like this, right? Because cos alpha is basically just this divided by this one, beta and gamma, right? So this how it is interlinked between each other, right? Yeah. So if you understand the concept also, unit vector only give you the information about the direction, right? Because the magnitude is 1, but it gives you the direction of the vector. And alpha, beta, gamma also only give you the direction. It doesn't give you the magnitude. It just gives you the direction. So unit vector basically is directly linked to alpha, beta, and gamma in that sense. Okay, so when we have multiple vector, how to add, the same concept applies, right? So I think we have done in 2D. If you manage to express 2 or more force in vector form, you basically just add the s component, add y component, add z component, right? Same concept, just that you have 3 components. So for example, if you have A is equal to AXI plus AYJ plus AZK, and B is as such, so if A plus B, just add the component, A minus B, just minus the component, etc. Right? So the thing is, as long as you can get the correct Cartesian vector form for each vector, then you can just add, find the resultant, etc. Like what we have done in 2D also, right? Important notes. Sometimes 3D vector information is given as magnitude and coordinate direction angle, or magnitude and projection angle. Now, two implications here. One is make sure you understand what is the term used. Coordinate direction angle is what, projection angle is what. Now, that coordinate direction angle is basically things like this, where you have the triangle, etc. Right? Projection angle is basically projection angle is this one. Basically, you project into the coordinate. Coordinate direction angle is alpha, beta, and gamma. So when you have questions, because sometimes the question only asks like this: find the magnitude and project that coordinate direction angle, for example. So it never asks find alpha, beta, and gamma. So you have to understand. Oh, it says this one. I need to find alpha, beta, and gamma. Just like in 2D, it doesn't actually specify find theta. It just find the magnitude and direction. But you understand, oh, theta is needed there. Right? That's one thing. Be familiar with the term. Second is that the question can give you drawing like this, or it can give you drawing like that. So you need to know how to deal with different type of information given. Yeah, so you might have to use the two triangle as before. Have you done that before? No, we only have one triangle, right? But for example, we have force and then the triangle, right? So I mentioned before, make sure you know how to use the triangle, because here you can have the double triangle that you have to use. Because if you want to change to theta, and then it will be too tough here. And when we say Cartesian form or Cartesian vector, it means IJK format. Right? So if the question says express your answer in Cartesian vector form, so it's in terms of IJK. Right? Okay, let's take a look at this one. First, do you understand the question? Two forces F1 and F2 are applied to a hook, so you have F1 and F2. Find the resultant force in Cartesian vector form. So if you remember the 3 steps of problem solving, IPE, then interpret is basically you understand what is given and you understand what is the final answer that you have to give, right? What is given, do you understand? The force, the angle, etc. What will be the final answer that you have to give in this question? There is a resultant, right? Resultant force in vector Cartesian vector format, right? So basically, in the end, you get, for example, F R in a vector format, right? IJK. That's the final answer. Okay, so if you understand that, next is plan, right? T. So how do you get that? How will you determine this one? So basically, if you can get F1 in vector form, F2 in vector form, you can just add the X component, add the Y component, and add the Z component, right? If you have that before. So the first task is how to get this one in vector form. F1 and F2, right? We have F1 and F2. So do you have any problem there? F1, F2. So okay, for F1, what is the X component? 0, meaning like this. How many of you agree with this? Only 2 people? 3. How many disagree? Yang ni tengah kira ke? How do you get 0? Yeah, okay. Do you understand what it means when it is drawn like this? Yeah, because for example, if you have, let's say x, y, z, and z, right? It's basically in y, z plane, right? When it's drawn like that, meaning that it's in this plane and then it goes down to that axis, right? Meaning it doesn't have any x component, because the component is only y and z. You understand? So that's why it's 0. What is the y component? 500 4/5 g plus 500 3/5. Okay, right? So we have touched on the how to apply the triangle before. Any problem here? Alright, so this is quite easy. What about this one? F2. What is the x component? Cos 45. Cos apa? 30. Cos 30. Lagi. Okay, how many of you can get this one? What about y? Cos 45. Sin 30. And then? Cos. And this? Betul kan ni? Okay, how many of you get this one? Only one, two. The rest of you? Okay. Normally, if you have never dealt with this one before, it will take you need to do the two triangles first, right? And then after you do that several times, this become automatic. So if you consider the light blue triangle there, right? If you look from the perpendicular to the plane, it will be like this. Can you imagine that? This blue triangle here, looking from this angle, right? Boleh right? Where this one is 45, right? That 45 degrees. Boleh bayang? Okay. Boleh tak ni? If you cannot even imagine it, this is a problem. Because in 3D, you have to first be able to visualize what is going on. Because kalau you nampak ni leper je, jadi lain. It's actually 3D, right? Okay, this will be 800, right? This one 800, the hypotenuse. This one is the z component, right? So let's put it F to Z. This one is this line here, right? Let's label it F prime. Okay, label F prime. Can you express F to Z in from this triangle? What is F to Z using this angle? This one, 800 sin 45 degrees, right? This one is 800 cos 45 degrees. Any problem with this triangle? No. So in terms of Z, this is straight away, right? 800 sin 45. Negative because it's going down. Okay, now if you consider this darker blue triangle there, if you look from top, it will look something like this. Can you imagine this one? Okay. If you look from top here, so this is F prime, and this is F to X, this is F to Y. Right? This is X, this is Y, which is this is Y. The hypotenuse is basically this, the same as F prime here. Right? So and the angle is, this is 2T, right? From this triangle, can you express F to X? If it f prime cos 30, f prime sin 30, right? And f prime you already know this one, you can plug in, right? So if you plug in 800 cos 45 degrees cos 30 degrees, you just plug in here. Here you plug in 800 cos 45 degrees, then you have sin 30 degrees, right? If you undo the bracket so that it's clear when you plug in. So that's why you end up with 800 cos 45 cos 30. 800 cos 45 sin 30. This is y, this is x, right? And make sure you understand why this is x, y. Because if you, from the perspective that you look of the triangle, kan x bawah, y atas. But it's, you can imagine this one, right? From the drawing. Any question? Anything not clear? Make sure you understand this, really understand this and know how to apply this, because as we mentioned, what we cover in chapter 2 and chapter 3 will normally in the exam the first part of a long calculation. In chapter 5, 6, 7, normally the calculation is long. All of this is the first part. So if you cannot do this one, then the rest is you learn you cannot do also, because you stuck there, right? So make sure you don't have any problem here. The faham? After you do this 3, 4, 5 times, you can do this in your head and still we can review like some of our time. Okay. But normally the first step you properly do this so that you can visualize the triangle and get the correct one. Someone can straight away visualize in 3D. For example, in 3D space, if this is x, y and z, right? And then this f2 here is actually somewhere here. It's between x and y and going down, right? And this is 45 degrees, and with x is 30 degrees, right? So those who can visualize, they can straight away, okay, I want to get x, right? So this one cos 45, cos 30, I get that one. Cos 45, sin 30, I get this one. Sin 45, I get this one. So siapa yang boleh visualize lah? It's basically, if you have done this one, you can, after some time it becomes just like you deal with sine, cosine or one triangle, right? The two triangles. Any question? Ada masa lagi nak drop course kalau okay. Now make sure, because things like this it involve because this is not just understanding what is going on, it's basically doing the exercise and it becomes some process that you understand what's going on, right? And also, as we mentioned in the exam, this is the first part on the long calculation, so this part should be just like 30 seconds and 1 minute. So if you take like 10 minutes here and 5 minutes there, then you do not have enough time for your exam. Right. Okay, because this is not static. This is mathematics. Right. Sin, cosine. This is not statics. Static is what we use after this. Right. Okay, so what is the question again? So the question is, what is the resultant, right? So if you already know this in vector, so this is what this x component is just 0 plus this one, you get x. Y component is this one plus this one, you get j, and then this one and this one, you get k, right? So for f1, for example, you get this value here, straightforward. But even though it's straightforward, make sure you understand how things are drawn in 3D. Right? This means is on this plane, so and because we do not have tutorial session this semester, so we only cover the example in the slide. That's number one. And I also mentioned before, the question in the slide is always the easiest type of question. So if you could see question like this, you see kenapa senang? Why is it too easy? Because that's the easiest question. The exam normally never that easy. But if you see, oh, it's difficult, I drop it. Meaning you have to normally it becomes difficult because you lack exercises, right? It's not familiar to you. Right. So okay, why I mentioned that one is because sometimes if you look at your textbook, there are a lot of different type of drawing that you can see. So make sure anytime you can, when you see, you can visualize how to calculate, right? Because it's not just like this, for example. Okay, this is when dealing with the two triangle. You have this one and this one. So if you have, because the slide is already available, so make sure you understand what's going on here, right? So this one is referring to this triangle, this one is referring to that triangle, basically. And then you can write that one. Okay. So after you have obtained both four, so resultant is just simply you add, you get this one. Alright? Okay. Concept quiz. This is to see whether you actually capture the concept. If you know only UA, you can determine the what of the vector A uniquely. A, B, C, or D. How many of you say A? Tadi macam dengar A. B. Ke tak boleh tanya juga. Tak ada depan. What is the answer? D. E. A. Magnitude. C. A, X, A, Y, Z. Do you understand the question? Okay, if we have vector A, and if we have this vector, the magnitude of A, the vector is A, and if you have a vector of magnitude 1 in this direction, this becomes U, A, right? The question says, if you only know UA, if you know this only, you do not know anything else, you do not know, you only know this one, meaning equal to blah 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 I plus blah 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 J plus blah blah K. That's the expression lah. So you know this only, you don't know anything else, you don't know this, you don't know that, etc. So what of A, what of this one, do you know? Do you know magnitude A? No, right, there's no information there, right? You cannot get from here. Do you know alpha, beta, gamma? No. Do you know A, X, A, Y, Z? How do you know A, X, A, Y, Z? Huh? Oh, jangan lupa. This one I, J, K. This and this is not the same, right? This one is AX, AY, Z. This is the unit vector and unit vector Y, unit vector Z. It's not the same thing. When you say magnitude AX, AY, Z, do you know? We don't know, right? We don't have any motion. All of you bukan. Sebab pun dia jawapan. You actually can get alpha, beta, gamma, right? Do you remember? Yeah, basically this one equal to cos alpha, this one is cos beta, this one is cos gamma, right? Basically this is just to see whether you because the concept is this one is actually the information about the vector itself. This one is actually the information about the direction. Same as this one. This is direction. Yeah. So it carries the same information. Okay. Tak apalah. Bersyukurlah soalan ni tak masuk exam. Senang je. Okay. Okay, let's take it. Okay, I'll give you 5 minutes. See how you get. Okay, first before that, let's see if you understand the question. So we have two forces, F1 and F2, given. So you have the angle and the angle. Find the magnitude and the coordinate direction angle of the resultant force. Do you understand what's the final answer that you have to give? Okay, this is different than the previous question because the previous question just want the vector, right? This one, you have to find the magnitude. And then, coordinate direction angle is alpha, beta, and gamma, right? How do you get this one? Is if you know FR vector, you can calculate this one. How to get FR is first you get F1 and F2, right? Okay, so try to express what is F1 and F2 in vector form. And see, because here you again have to deal with the two triangles. So let's see if you understand what we have covered just now.
Excuse me, Professor. Can we turn off the light in the front so we can see the?
We can, but it will turn off the whole light like this.
Okay, no problem.
Okay, we
Put
try.
it on, put it on, no problem.
Is it clear? You want to get the value, is it?
Yeah.
Okay, well, for like 30 seconds, do you get the value there? And then we'll switch it on back. So there's 120, 45 and 60, and then they have that 25 and 30. Right? Alright? So let's take a look whether you can actually determine what is the XYZ component of each F1 and F2. There's two different concepts here, right? Alpha, beta, gamma, and the triangles. Right? Tak keluar ni, patutnya ni 20 saat. Lama je kau mungkin segitiga. Mana vektor dia tak keluar-keluar. Okay, just to check. When you do the triangle, of course, one of the angles should be 90 degrees, right? It's a right angle. So for this angle, which angle is 90 degrees? Is it down here or up here? Here, up here. For this triangle, right? Everyone get the same? Okay, for this triangle here, is it down here or up here? Both. If it was 90 degrees, it's not a triangle, right? How many of you have here? Yeah? So it's up here? Why? Untuk gambar? Tak berdiri langsung. Now, you should be able to determine that it is 90 degrees here, right? Can you? Is it obvious or not? Oh, why? Why itu? Kenapa ke why itu sesuai? Now, for those who not clear, if you okay, for this triangle down here, which is the hypotenuse? This one, right?
Yes.
For this one, which is the hypotenuse? This one, right?
Yes.
Because this is the x, this is the y, right? And this is x, this is y, right? This is hypotenuse. So when this is hypotenuse, obviously this is the 90 degrees, right? So if you draw that wrongly, then your calculation will also be wrong. Anyone not clear on that one? Kenapa plus tu hypotenuse? Oh, lama ya. Okay, so if we draw the lower triangle, something like this. Okay, the triangle, how many of you get this, basically the same triangle? So if you get the same, then patutnya berapa sangat ingat? Okay. This one is what? 250 cos 35. This is 250 sin 35 degrees, right? So this one is f prime cos 35, f prime sin 25 degrees, and if you plug in f prime, you basically get here. Okay, for x is this one, so f prime is so 250 cos 35 sin 25i positive, right? Positive. Plus 250 cos 35 cos 35 j going down minus 250 sin 35k. So is it correct? 20 seconds, 20 seconds, 20 seconds, right? 1 minute. So make sure you can do it in roughly that time frame. Yang lamanya apa? Nak lukis ke apa? Tengok. Okay, make sure you can visualize If you cannot go there from there to the triangle, then make sure that one is not. Meaning, if you cannot visualize from here to the triangle, that's not static. That's not even mathematics. That's you have to check your eye. Because, or you have to the perspective of it, right? Now F2. Anyone already calculated this one? But they have x component? How do you get 0? Should be what? 400 cos 120 I plus 400 cos 45 degrees J plus 400 cos 60 degrees K. This one is the easiest one. Because whenever you get alpha, beta, gamma, you just plug in the value, you can straight away calculate. Okay, 15 saat tadi. And of course, you have to do the calculation again. Now, notice that if you notice that F2 here, the x component is actually negative direction, right? It's going the back there because positive x here. But do not put negative here because the negative will automatically come when you do cos 120, you get negative. So when you deal with alpha, beta, and gamma, you just plug in and then positive and negative will come naturally. For this one, you have to put negative because you have to manually put whether it's positive direction or negative direction. That's the difference. Okay. If you have this one, can you get FR the vector? Basically, you just add basically that I plus J plus K. You just add the x component, y component, z component, right? How to get the magnitude? Square root square. How do you get the alpha? Cos -1. You get the x component over FR, right? Basically, this is FR x over FR. Theta cos FR y over FR, etc. Right? So once you get this one, you just plug in. Okay, Fx and FR plug in here, Fy and FR plug in there, Z and FR plug in there. Normally, if you have done several times, this become automatic. Once you obtain this one, the rest is just calculation, right? If you make mistake here, then or if just now ditenung lama, then itulah jangan problem lah. So normally that's the trend in the final exam. There's two trends. One is those who are very busy. Normally good student will be very busy in the exam because there are a lot of calculation to do. And those who have lack of preparation, normally they will become very boring because they do not know what to do. Right? So that's a signal also. That you do not know, because normally the exam the time is just enough for you to solve. Right? But of course, normally from the way we allocate time in the exam, it's like this. Because it's not fair to expect you to be able to solve as fast as me, right? Because I'm teaching this one and you're just learning. So normally the way I check whether the time is enough or not is normally like this. I take the exam paper, I try to solve while watching movie. Okay? So if I can solve in that time, I give double the time, you should be able to solve. Sebab you tak tengok movie, tak makan. So it is. So normally that's how time is given. Normally I do not try to solve seriously because that becomes shorter time, right? So tengok movie, oh, dah tambah. So if you actually have double time, you should be able to solve, right? Okay. So F1. F2. So this is, you can check your calculation, right? So as you can see here, okay, note that here actually we get a negative value here. This value is negative. When you do here, negative must be inside here. You have to take all because this negative will make the value more than 90 degrees. here it become 104, right? Similar when we start, when 120 degrees, for example, it become negative. So make sure you understand that concept. Normally this thing becomes more, how to say, when you do the exercise, normally this is how we learn. When you do the exercise, normally we tend to make mistake somewhere, and we check, we realize what mistake we tend to make, and then we tend to remember that, and we do not repeat, right? So that is where it's good to have mistake when you do exercises, so that you realize where you tend to make mistake, or even in the class, right? If you make a mistake, it's easier to remember because lagi malu lah kelas kan. But it's better to have that experience not in the exam. Biasa lepas tu lepas keluar exam baru then dah tak apalah next semester lah. Okay, attention please. What is not true about unit vector? Dimensionless, is it true?
Yes.
Magnitude of 1?
Yes.
Always point in x-axis?
No.
Right. What unit vector is on x-axis? I, right? Okay. This is not, because this is the attention quiz, whether you are paying attention or not. So if f is 10i plus 10j plus 10k, g is 20i plus 20j plus 20k. If you add the two vectors, you get 30, 30, and 30, right? Alright, that's the end of this part. So we have another 2 parts to go. Alright, so we go into another part, which is position vector and force vector. Right? So what we have learned so far is mainly how to deal with angle, right? Meaning how to magnitude towards vector, where you have different type of angle given. In reality, it never actually that easy. It's not exactly that straightforward, because if you have a structure like this, no one will actually give you alpha, beta, and gamma, for example, right? If you see the structure, you will never see, oh, to alpha, it doesn't come, right? So the thing that you can measure is, okay, this distance, that distance, right? So we have to know how to get from the real actual thing that you can measure to the calculation, so it becomes longer. Right, so we have this concept of position vector. Okay. So in terms of application also like this, right? For example, okay, we don't know the angle because the triangle is not appearing here. How to get the angle? Many real situation, right? So we have to know how to deal with this one. Okay. Okay, position vector. Have you learned about position vector before? No. So position vector is basically just, when the name is position vector, it's actually a vector, of course, but it relates to points basically. So if I have point A here and I have point B here, and the vector is from A to B, so I can express the position vector from A to B. This is basically position vector, and we write it as R. So if I get from B to A, it will be RBA. That's how we know it. So RAB is from A to B, RBA from B to A. It will be the opposite direction. It will be different vectors. Right? How to calculate is basically if you know the coordinate, right? So if here is X A, Y A, Z A, X B, Y B, Z B. So for RAB, it's basically just you take the destination or the end minus the beginning here. So basically you get XB minus XA I plus YB minus YAJ plus ZB minus ZA K. You understand? If RBA, then it's the opposite, A minus B. You understand the concept? Right. So this is where we can get a vector from just the coordinate, because the coordinate can be measured in any real application, right? We have a way to determine the coordinate. Right. So this is okay. This is basically what we mentioned here. RAB is basically just coordinate of xb minus xgi, yb minus yaj. Is basically this one here, right? Please note that B is the ending point and A is the starting point. Always subtract the tail coordinate from the tip coordinate, or whatever word, the end from the beginning or the destination from the etc. Right? So the final point to the beginning point. Okay, that's position vector. Force vector directed along a line. Now, why are we concerned about this one? Is because like this. We have said before, right? If we have, let's say, a force directed along a line. For example, here we have force. For example, this is a cable, so we have a force here, and the magnitude. This is the magnitude. This is the vector. Now, if you know the magnitude, to get the vector, just now we already have learned about unit vector, right? Where the magnitude is 1. How to get this unit vector? Right. Unit vector is basically any vector along the line divided by, of course, for f is basically f equal to f u, right? Or u equal to f divided by f. But this one is the final calculation that we want to use, right? So if we can get any other vector, the simplest is basically if you know the coordinate, you can get what is r. Right? Because if you know this coordinate, you minus, you get r from this point to this point. If you get r, can you get the magnitude? Basically square root. You get that? Because it's a vector, you get magnitude. If you know this one, if you divide, what you get? You get unit vector, right? When you get unit vector, you multiply by this f, you get this one. So that's basically the chronology. So that's why first, basically, what is the coordinate? From the coordinate, you can get this position vector. Of course, the magnitude. Of course, unit vector is basically just r divided by r, the vector divided by magnitude. And then the force is simply just f times unit vector. Okay. So this is why we learn about this position vector here, because we can use data from real that we can use coordinate and then use to get the unit vector, and then you just multiply by the force. Yeah. So this is basically the same chronology there. Of course, here I like to split the, because here is stick with r and then divide by magnitude, we get u. Same thing. Right? But I put coordinate also a step because sometimes some students actually need to learn how to get the correct coordinate, right? Because it's not that they do not know, but in terms of exam, sometimes you get the mistake in terms of positive, negative coordinate, etc. So make sure you really practice on that to avoid mistakes. Because it will be very unfortunate, because if you get the coordinate wrong, then it will affect the whole calculation. Right. Example. Okay, so in this case, we only focus on one force 420. Right. Normally the question is more complex. You have two force and you need to find resultant, etc. Right? But the first step is always express one force, all the force in vector form. So now we are just practicing on that. So if we're focusing on this force, to get in terms of Cartesian vector form, what do we need? First, the coordinate, right? Okay, so let's try this one. So the coordinate that is relevant to us is coordinate A and C. Right? So coordinate of A is what? 0, 0, 0, 6. Coordinate of C is
3, 2, 0.
Is it? 2, 0, right? Do not make mistake there, right? Because this is X, this is Y, right? If you know the concept why you make mistake there, then it's It's very sad. It's a sad story. Okay, so then AC, right? What do you get? How to get this one? So this point C minus point A, right? So 2 minus 0 is 2I. 3 minus 0 is plus 3A. 0 minus 6 minus 6. Okay, what will be the magnitude? So basically 2 square, 3 square, you get 7, right? Of course, if you want to be accurate, this is meter. So unit vector of AC, basically this one divided by this one, right? So you get 2 over 7 I plus 3 over 7 J minus 6 over 7. Okay, up to this point, any question? Anything not clear? Coordinate, position vector, you minus, this one square root, this one you just divide. After this, what you get? You just multiply by, so F is simply just the magnitude times unit vector, right? So F is C here, 420 times all of this, right? 2 over 7 I plus 3 over 7 G minus 6 over 7. Okay, then you get the vector. Of course, the exam will never give you this question, because if you see it, there will be another force and then you have to resultant, etc. Right? That will be the first. So normally this cycle is the first step of the calculation. So for example, the question gives 3 or 4 force, so you have to repeat this for 4 times and then you add, for example, extra. Itu kalau nasib baik 4 lah. Okay, so yeah, so but now we are focusing on this part, right? Because this is the first part of the calculation. Any question? So let's see. So if you do the calculation, you'll get that one, right? That value. Do you understand the concept? Should be straightforward, right? It's just that again, on many of these part, chapter 2 is not that much of the difficulty to understand the concept. It's more towards how much practice you have and how the calculation becomes straightforward for you. Concept quiz. Okay, if P and Q are 2 points in 3D space, how are the position vector are PQ and are QP related? Straightforward, right? Which one? B, right? It will be negative to each other because it's the opposite. Okay, this is just to see whether you can deal with unit properly. If F and R are force and position vector, meaning F is force, R is position vector. So if you do this calculation, R multiplied by F divided by F, the unit will be what? Is it? Is it? What is the unit for R? Meter. Is it? Meter, right? Because the position there, right? This one? This one? You cancel, become? Meter, right? Macam mana jadi jelek? Alright. Okay. So we have 2 forces acting on a flagpole as shown in the figure. So FB is 560 and FC is 700. Find the magnitude and coordinate direction angle of the resultant force. Alright, do you understand the question? What is given? You have to force and then you should be able to get the coordinate and proceed, right? What will be the final answer? Magnitude and? What is the coordinate direction angle? Alpha, beta and gamma, right? Alright, so the step will be as we have done before, right? if you can get F1 and F2 in vector, you can get resultant and then you get the magnitude alpha, beta, and gamma. So how to express each of these in Cartesian vector form? So we have this cycle here, right? So in this case we have 2, 4. So first we focus on AB, right? So if you have point A, point B. So coordinate of A is 0, 0, 6. Coordinate of B is 2. Is it 3? Negative 3. 0, right? Make sure do not make mistake, because if you forget the negative, your calculation will be affected throughout, right? So always, even though this is simple, but to make mistake also simple in this step. So the y is negative. So in this case, R AB is B minus A. So we have 2I minus 3J minus 6K. The magnitude will be 7 again, right? In the exam you cannot write like this, right? You have to write full, but yeah, because 2, 3, 6 just like the previous question, right? Become 7. So unit vector of AB is 2 over 7I minus 3 over 7J minus 6 over 7K. You follow? So then FAB will be, what is the value? 560. So 560 times this whole thing, 2 over 7I minus 3 over 7J minus 6 over 7K, and you can simply calculate the answer there, right? Anything not clear? Basically this is the same cycle as before. What about AC? So point A to point C. A is again 0, 0, 6. C is 3. Negative 2. 0, right? So RAC is 3I plus 2J minus 6K. RAC is 7 there. U is C is 3 over 7I plus 2 over 7J minus 6 over 7K. FAC is basically 700 times the whole thing, right? And then you get that. Of course, the rest is just FR is basically you add the component, right? And well, question before, right? When you calculate until x alpha beta gamma, so you know what to do. Yeah, so you get the magnitude and then you get cos alpha beta and gamma equal to 1. So just if you want to check the values, so FAB you get this value 160 minus 240 minus 4 is 0. FAC you get 300I plus 200J minus 600K. Then you get the magnitude there. Of course, from here, then alpha is just simply cos squared 460 over 1175, right? Beta is negative cos negative 1, negative 40. Make sure you take inside the calculation the negative value, right? As you should see here, right? So the negative 40 and negative 1080, the negative should be there so that the angle is more than 90 degrees. And then that will be the answer. Any question? Anything not clear? Boleh kan? I believe you can already access the slide, right?
Yes.
So you can verify the. My main concern in the class is more towards if you understand the flow or not and what to do, right? And just the exact specific calculation you can verify with your calculator. That's not really the problem. But of course, for preparation of yourself, it's not enough just knowing the flow, because normally the mistake is also in terms of forgetting to put something, right? So make sure you try also actually solving some of the problem. Attention quiz. Alright. So just to see if you are paying attention. If you have 2 points, which P is 1, 2, 3 coordinate, Q is 4, 5, 6. Position vector RQP will be which one? A, B, C, D, or E? Okay, which one minus which one? So that's the thing here, right? So P minus Q, you'll get a negative answer, right? So it should be P, right? Okay, if you have a force vector F directed along a line defined by PQ, that F can be given by minimum. Which one will be equal to F? Vector F. Which of these equal to F if the direction is along PQ? Why? What is this actually? This become unit vector, right? Where we split this one, right? So and you multiply by F, you get vector F. Alamak, habis. Alright, so we only have one part left. Tapi semua dah bunyi dah. Okay, so we reserve that for the next class. Because, okay, according to the schedule, week number 3 we should already start chapter 3. So we are a bit behind, but hopefully not that much. But this one is also. So, but you have learned the dot product before, right? Okay, so that will be next week, inshallah. Right. So one thing is most probably we will have quiz in the next week or next class. So be prepared with what we have covered so far. Right. What else? Make sure you have enough practice so that when we go to chapter 3 onwards, this part is settled. Okay, with that, semua tak sabar-sabar nampak. Okay, so we end the session. InsyaAllah, subhanakallahumma wa bihamdika, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.